For most of human history, the night sky appeared complete. Ancient civilizations gazed upward and imagined a universe filled with meaning. They connected stars into stories, transformed constellations into gods and heroes, and believed the heavens were fixed above them like a perfect celestial ceiling. As centuries passed, observation replaced myth. Astronomers discovered that Earth was not the center of existence. The planets followed predictable paths. The stars obeyed physical laws. The universe seemed increasingly understandable. Yet every major discovery carried an unexpected consequence. The more humanity learned, the larger reality became. When telescopes improved, our place in the cosmos shrank. We learned that the sun was only one star among billions. Then we discovered that our galaxy was only one among trillions. Every answer opened a door to even greater questions. And in the 21st century, humanity built a machine designed to push that process farther than ever before. The James Webb Space Telescope. Unlike previous observatories, Webb was not built merely to see distant objects. It was built to see distant time. Located nearly 1.5 million kilometers from Earth, Webb operates in deep space beyond the interference of our planet's heat and atmosphere. Its massive gold-coated mirror captures infrared light with extraordinary sensitivity. This capability is crucial because the universe is expanding. As space stretches, ancient light stretches with it. Light that was originally emitted as visible radiation billions of years ago arrives today shifted into infrared wavelengths. To observe the earliest moments of cosmic history, scientists needed an instrument capable of detecting those faint infrared signals. Webb was designed for exactly that purpose. In effect, it functions as a time machine. Not by traveling through time, but by collecting light that began its journey billions of years in the past. Every image captured by Webb is a glimpse into history. Before Webb, the Hubble Space Telescope transformed our understanding of the cosmos. One of Hubble's most famous achievements came when it focused on what appeared to be an empty region of space. The area was astonishingly small. A patch of darkness so tiny it could be covered by a grain of sand held at arm's length. For days, Hubble stared into that darkness. When the final image appeared, astronomers were stunned. The emptiness vanished. Thousands of galaxies emerged from what had seemed to be nothing at all. Each galaxy contained billions of stars. Each star potentially hosted planets. What appeared empty was actually overflowing with structure. The lesson was profound. The universe was far larger and more populated than anyone had imagined. Yet even Hubble had limits. The earliest galaxies remained hidden behind the veil of cosmic expansion. Their light had shifted too deeply into infrared wavelengths for Hubble to observe clearly. Webb was built to cross that boundary. Scientists expected it to provide sharper images and more detailed observations. Instead, it began delivering surprises almost immediately. When Webb looked deep into cosmic history, it discovered enormous numbers of galaxies existing far earlier than expected. Some of these galaxies appeared surprisingly mature. Rather than chaotic collections of stars slowly forming over time, they already displayed organized structures. Several appeared massive. Some showed evidence of developed shapes. Others contained unexpectedly large amounts of material. These observations challenged assumptions about how quickly galaxies should have formed after the Big Bang. The early universe was supposed to be a place of gradual construction. Instead, Webb revealed signs that complexity may have emerged far faster than predicted. And that was only the beginning. Because hidden within those ancient galaxies were clues suggesting that stars had already lived, evolved, and died multiple times. The universe seemed to be growing up faster than expected. And if that conclusion proves correct, it could reshape our understanding of cosmic history itself. For the first time, humanity was not merely observing the universe. It was witnessing the opening chapters of creation. And the deeper Webb looked, the stranger those chapters became. The universe is not a random collection of galaxies scattered through empty space. On the largest scales ever observed, it resembles a vast cosmic network. An immense structure stretching across billions of light years. Astronomers call it the cosmic web. Gigantic filaments of matter connect galaxy clusters across unimaginable distances. Between these filaments lie enormous voids, regions where relatively little matter exists. Together they form one of the largest known patterns in nature. Yet what makes this structure even more remarkable is that much of it appears to be shaped by something invisible. Dark matter. Unlike ordinary matter, dark matter does not emit light. It cannot be directly observed. No telescope can photograph it. And yet its gravitational influence appears everywhere. Galaxies rotate too quickly for their visible mass alone to explain. Galaxy clusters remain bound together despite lacking sufficient observable matter. Large-scale cosmic structures behave as though an unseen framework supports them. Many astronomers believe dark matter acts as the hidden scaffolding upon which galaxies form and evolve. But even this explanation leaves unanswered questions. Webb continues to reveal structures in the early universe that seem unexpectedly advanced. Galaxies appear sooner. Complexity emerges faster. Patterns develop earlier. Whether these observations require adjustments to existing models or entirely new ideas remains one of modern astronomy's most exciting mysteries. Yet Webb's mission extends beyond galaxies. It is also transforming the search for worlds beyond our solar system. For thousands of years, planets around other stars existed only in speculation. Today, they are scientific reality. Thousands of exoplanets have already been discovered. Some are larger than Jupiter. Others resemble rocky worlds closer to Earth. Many orbit stars hundreds or thousands of light years away. Although these planets remain far beyond our reach, Webb has found a way to study them. Through a technique known as spectroscopy. When light passes through a planet's atmosphere, specific molecules absorb particular wavelengths. These missing wavelengths create patterns that act like chemical fingerprints. By analyzing those patterns, scientists can determine the composition of distant atmospheres. Water vapor. Carbon dioxide. Methane. Oxygen-bearing compounds. The chemistry of alien worlds can now be investigated using nothing more than light. It is one of the most extraordinary achievements in human history. Without leaving Earth, humanity has learned to examine skies orbiting distant suns. Every spectrum collected by Webb is a message from another world. A coded record describing temperature, atmospheric composition, and environmental conditions. Some planets appear hostile. Others show intriguing signs of complexity. Future observations may even reveal combinations of chemicals associated with biological activity. No definitive evidence of extraterrestrial life has been found. But for the first time, humanity possesses tools capable of searching for it with unprecedented precision. Perhaps that is Webb's greatest achievement. It is not simply a telescope. It is a bridge. A bridge connecting a small civilization on a rocky planet to the deepest reaches of cosmic history. Every photon captured by its mirror began a journey long before humanity existed. Some originated before Earth formed. Others traveled across billions of years of expanding space before arriving at a machine built by human hands. Those ancient particles carry stories. Stories about the birth of stars. The formation of galaxies. The evolution of worlds. And perhaps the origins of life itself. The remarkable truth is that the universe remains unfinished from our perspective. There are still mysteries hidden in the darkness. Questions without answers. Structures not yet understood. Webb may uncover the earliest black holes. It may reveal entirely new classes of galaxies. It may challenge theories that have stood for decades. Or it may expose phenomena nobody has even imagined. History suggests one thing with certainty. Whenever humanity develops a more powerful way of observing reality, reality responds with surprises. And somewhere beyond Earth, beyond the planets, beyond the stars, a golden mirror continues to drift silently through space. Watching. Collecting ancient light. And helping humanity read the story of the universe, one photon at a time.